Hi everyone, how are you today? So, for today, data mining Friday lab, we have to do the work on our team dataset to pre-process reduce the input variables to no more than six and normalize them, and we have to ensure our variable output variable should be categorical. We have to use TensorFlow and in the Google Colab to build neural network, and we have to explain the output variables. We have to use the softmax earlier in that one. Then we have to do our confusion matrix and classification report to test the quality of the model and explain the tests what we have done. So here are the codes for our Friday lab work. And so let's start now. Okay, so beginning from the first question, pre-processing our data comes first. So first I have imported all the packages that was required, like pandas, tensorflow, numpy, matplotlib, and keras, and sklearn, confusion matrix, and classification reports packages. I have we can see I have uploaded our data set, which is insurance.csv. Here we can see here, this is my data, and insurance.head, and we can see the data here. So first of all, what I have done, I have drop rows with non-values, and in place is equal to true. Then binning the target variable into 5 categorical bins as it's stated, and encoding the non-numerical independent attributes like smoker, region, or sex, and encoded the target attributes, which is charges. So, and after transforming, we can see here the charges data set. It's in the different column, and as we see, like it was stated no more than six layers, so all parameters are fixed to six, and class labels are charges, insurance, x and y. And after I have split the data. um, 66% training and 34% testing, x and y, and test size is equal to 0.34. Testing is 0.34 divided by 100, so it comes 0.34. So after, like, here comes our main attribute for the questions. Like first, define the neural network. A sequential neural network model from Keras model is equal to tf dot keras dot sequential. The input layer with 24 neurons, then 24 activation ReLU, input shape is equal to 6. The next hidden layer with the 12 neurons uses ReLU activation. Here it is. Then the hidden layer with 8 neurons, and the output layer with 5 neurons with the softmax activation. Input data and uses softmax activation, and the 5 and activation is equal to softmax. So after that, I have compiled our model using Adam optimization and the loss function called spats categorical cross entropy, and the matrix is used for printing the accuracy after each epoch. So the epoch is the sets are equal to 500, x and y train, verbose equal to 1, and we can see here 500 and all that results, accuracies, loss, and which states different accuracies and different loss for each test epochs. Then after I have predicted the values for the test data set. Here's the code for that one. Prediction is equal to model dot predict x test. Then the predictions are in the form of class probabilities because of the softmax. So saving only the class with the largest prediction value, that is our prediction. And the underscore dash prediction is equal to np dot argmax prediction dot x is equal to 1. After that, we have to evaluate our model with the classification and confusion matrix report. So my f1 score was 0.94, and with a support of 358, accuracy is 0.88, macro average is 0.61, weighted average 0.89, which is quite good for 0.88 accuracy, which after getting the classification report. So converting the predictions to confusion matrix. Now I have plot the confusion matrix here with the axis 1 sum, and visualizing the matrix, figure size 8 by 8, true label and predicted label. So true label on the left side and predicted label on the bottom. So here we can see it's 1 with the true label and predicted variable. We can see it's 1. So after 0.51, 0.48 with, and after comes again, if comes here 1, the red bottom one predicted label. So after that we have to explain our confusion matrix, our neural networks and model explanation. So here is the model explanation which I have done here. So my neural network has 4 layers with the following configurations. Layer 1 has 24 neurons with the ReLU activation and input size. It's 6 features, as I have also stated here. We can see here all of the data which I have, like 8 and 5 layers, 8, 12 and 5 neurons. Here we can see here. Okay, so layer 2 has 12 neurons with the ReLU activation. Layer 3 has 8 neurons. Layer 4 has 5 neurons of 5 output classes with softmax activation. So the dataset has been split into 66% and 34% testing set. As I have stated in the start of this video, 0.341. We use the same splitting ratio for MLP in a previous lab too. We have used it again for a uniform results comparison. So our model trains on the insurance dataset for 500 people with the training accuracy maximizing to 88.22% and a loss minimizing to 0.3980. The test accuracy is 0.88, which equals to 88%. So the MLP I made is the previous lab has similar results, 87% to the current neural network, 88%. The number of correct class-wise prediction and accuracies is negligible. There is no major difference apart from the fact of the MLP was done to sklearn library and this neural network was designed using TensorFlow. And that was all from my side. I hope I have covered almost everything which was given in the assignment for our Friday lab to work on our team datasets. So thank you so much.